Until now, we have been discussing carbon capture from large point sources, where CO2 percentage in the emission stack is in the range of 20% and above. In our race to reaching net zero, transition to renewables and carbon capture from hard-to-abate industries is not enough. Historically present emissions in our atmosphere is causing irreversible damage to our climate. CO2 in atmospheric air is in the 420 ppm level, which needs to be captured. Direct air capture is best suited for this application. We can't talk about this technology without mentioning Climeworks, who is the industry-leading developer of direct air capture technology. I was, in fact, very excited to see this technology myself, and Climeworks was kind enough to host me at a facility in Switzerland. When we are trying to achieve net zero, hard-to-abate industries are already prototyping many, and in fact maturing many carbon capture technologies. Many industries are also looking at zero emission fuels to power their operations. But at the same time, we should not forget that balancing out the historically present emissions which are in our atmosphere needs also to be removed. And that's where the answer to this problem is direct air capture. One company which has not only matured this technology, but as well being successfully deployed it globally is Climeworks. I have with me Natalie Casas. So how did you manage to get this technology matured at the same time successful?
So the beauty of our technology is that it's very modular.
Okay.
If you look at it, you see many of the same type of boxes.
Okay.
In this box, we have a filter material which is able to capture CO2. And the process goes as this. So we blow air through the box. When the filter material is full, we close the box and we start heating. For heating, we use waste heat. As we do it here in Switzerland, we get heat from the waste incineration below our feet. And using this heat, we bring the filter material up to 100 degrees. That's when the CO2 is released and can be collected. And the successful, bringing it up to scale, in our case, it's the modularity. So we test everything at a small scale and then we multiply. So this enables us to de-risk at the small scale, which is cheap, and then upscale pretty fast because we just do the same thing as we did before, but just more of it.
When you mentioned that you are utilizing the waste heat over here coming from the incineration plant, I know that you have an installation in Iceland as well. Where do you get the heat over there from?
In Iceland, we get the heat from the geothermal power plant just next to us. So this is a crucial fact for Climeworks. We are committed to work only with renewable energy sources. So waste heat is one of the best.
When we look at the scale at which you are operating, like modular systems, how high can I go in terms of achieving decarbonization targets with this technology?
Yeah, that's a very good question. We even get sometimes the question, are you not taking the CO2 away from the plants? Okay. Of course, there is enough CO2 for plants and there is still too much for the atmosphere. So we did some calculations in this respect. And what we needed to understand is how is the air behaving around our plant. And our CFD simulation showed that we can go up to at least 3 million tons a year at one single location, and that there will not be any problem in terms of depleted air.
And how large is the single plant capturing right now for you?
So for the moment, we have these two plants here in Switzerland, which capture around 600 for the smaller one and 1,000 or 900 the bigger one. And the one in Iceland captures about 4,000 tons a year.
Okay. Now, when I look at a plant, and you are also an engineer, when you look at this plant, how did you find optimization opportunities? Which were the key parameters you figured out that this would help us optimize this plant?
Yes, so if you look at our technology, the main factors we need to optimize is cost. So we need to become cheaper and we need to become more energy efficient. So we tackle both. one thing you always can work on is the filter material. So this is the heart of everything. However, there are many opportunities also in optimizing the process. So making different steps longer, hotter, more pressure, less pressure. So you have many different handles you can play with.
Okay, so by changing pressure, temperature, etc., you can achieve, and you need a reliable solution for that as well.
Definitely. Reliability is very, very important factor. So if you imagine that your plant shuts down many hours a year, this just hits your costs because you're not producing.
Now this carbon dioxide which you capture, this stream of carbon dioxide, are you utilizing it for a certain purpose, or how is it?
Yes, so we have two different business models. One is the circular economy. This means we capture CO2, we use it, and it's released to the atmosphere again.
Okay.
There we have different customers. So these two plants here in Switzerland, they serve exactly this circular economy. So part of it goes to the greenhouse over there in order to fertilize plants. And the other plant produces CO2 for Coca-Cola.
Okay.
So the carbonate in the mineral water is partly done by CO2 of the air.
So next time I drink water, it's in fact carbon negative. Do you mean to say that?
It's not really carbon negative, it's carbon neutral because it's the circular approach.
Okay.
In order to become negative, we need to store it somewhere where it's away from the atmosphere.
Okay.
And this is what we do in Iceland.
In fact, mentioning about Iceland, I got a rock from your colleague. Looks quite interesting. What exactly is this made of?
Yes, so if you look at it, this is a basaltic rock which is in the subsurface of Iceland. The white little crystals here are carbonated CO2.
Okay.
This means if we send CO2 into the subsurface in Iceland, it reacts with the basaltic rock and forms these carbonates. And like this, it's permanently and safe stored underground.
Okay. Any key, let's say, when we are talking of decarbonizing, there is a lot done by industry in terms of carbon capture technology for large point sources, etc. But then there are scope 2 and scope 3 emissions, which customers also want to decarbonize. Are there some companies which have signed up with Climeworks to actually decarbonize their scope 2, scope 3 emissions?
Yes, indeed there is. So there is the Science-Based Target Initiative where many companies commit to a net zero 2030, 2050. And some of the companies do it with us. So we have a famous customer like Shopify, like Microsoft, LGT Bank, BCG, so Boston Consulting.
Boston Consulting, okay.
Yeah, so we have many companies who really make it serious. So they do not just talk about it, they really do it.
In addition to that, do you have any message for our audience today?
Yes, so I think the problem is here, the problem is huge, and we need everybody to contribute. So the vision of Climeworks is to inspire 1 billion people to reverse climate change. And I hope you will all be part of it.
Definitely. So remember, 1 million people need to join this movement so that you can decarbonize, and direct air capture technology developed and matured by Climeworks will help you reach there. With this, back to the studio. 3 takeaways at this moment. While the CO2 captured using direct air capture technology is currently shipped in small quantities for use in the food and beverage industry and enhance agricultural production in greenhouse. CO2 captured can be stored in geological structures, thereby removing CO2 from atmosphere permanently and results in negative emissions. We have an example of carbon storage coming up soon in our masterclass. CO2 captured is combined with hydrogen to produce synthetic fuel, thereby reducing carbon intensity by recirculating the atmospheric carbon. To know more about this, hang on, as we have a speaker from a Swiss Premium Research Institute talk about synthetic methane. If you are looking to reduce your scope 2 and 3 emissions, or would like to know more on this, put a comment in the chat window so we can get back to you.